There is a heating system that has worked for 3,000 years. The Koreans built it, the Romans perfected it, the Chinese scaled it to 175 million people. 90% of South Korean homes still use it today. It requires no electricity, no moving parts, no maintenance, no monthly bill. In 1822, researchers tested a 400-year-old version at Malbork Castle in Poland. They lit a fire beneath a chamber of granite boulders. 20 minutes later, an 850 square meter banqueting hall, nearly the footprint of a modern American mansion with ceilings 3 stories high, rose from 6 degrees Celsius to 22.5. 4 centuries old. Still working. 20 minutes. The physics has been proven since before the Roman Empire. The material costs $16 per cubic meter. A homesteader on a farm built one for under $300 and held 600 degrees overnight. Yet no UL listing exists for any residential sand battery. No building code in 49 states provides a pathway. No appraisal system can value it. The American Gas Association calls electrification an existential threat in internal communications and has passed preemption laws in 25 states. This is not a story about ancient history. This is a story about a technology so effective, so cheap, and so unmonopolizable that modern industry had to pretend it does not exist. Welcome to Off-Grid Secrets. The archive opens in 1822 at Malbork Castle, Poland. The fortress had stood for 5 centuries. Its banqueting hall stretched 850 square meters, nearly the footprint of a modern American mansion, but with ceilings 3 stories high. Heating it should have been impossible. The researchers who arrived that winter came to test something the medieval builders had left behind, a chamber beneath the floor filled with granite boulders stacked on furnace vaults. They lit a fire. They fed it 0.7 cubic meters of spruce wood over 3.5 hours. Then they waited. 20 minutes later, the hall had risen from 6 degrees Celsius to 22.5. Not over hours. Not overnight. Just 20 minutes. 4 centuries old. Still working. 20 minutes. They coded it out. They can't code out physics. Subscribe. The next archive opens soon. Now let's get back to the investigation. The system was a heat storage hypocaust, an evolution of a technology the Romans had perfected 1,500 years before the castle was built. But the researchers at Malbork were not discovering something new. They were rediscovering something that every civilization with access to stone already knew. The archive reaches further, to Eungi in present-day North Korea. Approximately 1000 BCE, the Koreans called it andol, meaning warm stone. An external furnace burned fuel outside the living space. Hot flue gases passed through channels beneath thick stone floor slabs. The thermal mass absorbed the heat and released it slowly over 12 to 24 hours. The fire could die. The floor stayed warm. By the Joseon dynasty in the 15th century, andol was standard construction across the peninsula. The wealthy built it. The poor built it. It was not a luxury. It was how you survived a Korean winter. Today, over 90% of South Korean homes still use radiant floor heating descended directly from andol. Frank Lloyd Wright encountered the system while working in Japan in the 1930s. He adopted it for his American designs. He called it one of the most important heating innovations he had ever seen. 3,000 years, 90% of a nation, still in use. And in northern China, the tradition runs deeper still. The kang is a heated sleeping platform, a masonry bed connected to a cooking stove by a flue system. Archaeological evidence from Heilongjiang province dates the first kang to the 1st century CE. Contested claims from Tongji University researchers push the timeline back 7,000 years. The scale of adoption is staggering. As recently as 2004, 67 million kangs served 175 million people across 14 northern provinces. Not electric heaters, not gas furnaces. Thermal mass platforms storing combustion heat in brick and stone, reducing building heating loads by 50 to 80%. 175 million people, not history. Present tense, the Romans engineered it, the Koreans perfected it, the Chinese scaled it, and the Finns never forgot it. In 1980, Reijo and Elisa Valkonen founded Tuulikivi Corporation in response to the oil crisis. Their solution was ancient, soapstone masonry heaters weighing 5 to 7 tons, absorbing heat from a 30-minute high-temperature burn and radiating warmth for 24 hours afterward. No electricity, no moving parts, just thermal mass doing what thermal mass does. Over 300,000 homes worldwide now use Tuulikivi fireplaces. And when a Finnish startup called Polar Night Energy built the world's first commercial sand battery, they filled it with 2,000 tons of crushed soapstone sourced from Tulikivi. The material lineage runs directly from 19th century Finnish stoves to 21st century grid-scale storage. The physics never changed. The insight never vanished. Every civilization that built with stone already knew that dense, common materials store heat for free. The question was never whether it works. The question is how much heat, how cheaply, and why no building code in America acknowledges it. In 2011, a mechanical engineer named Jiwon Ma began studying particle-based thermal energy storage at the National Renewable Energy Laboratory in Golden, Colorado. His original focus was concentrating solar power using mirrors to generate extreme heat for electricity production. But the principle he investigated was older than any power plant. Heat something up, insulate it, extract the heat later. When Ma's team calculated the storage costs for sand-based thermal systems, the numbers seemed wrong. $4 to $10 per kilowatt hour. A home lithium-ion battery stores energy at $300 per kilowatt hour. Not a small difference, a 30-fold difference. A 2,500 to 1 ratio in raw material costs when you compare sand at $16 per cubic meter to lithium-ion cells at $39,600. His colleague Craig Turchi, manager of NREL's Thermal Energy Science and Technologies Group, explained the logic this way. Once you've paid for the upfront cost, if you just want more duration, it's much, much cheaper to add more sand than the alternative, which is to keep adding batteries. Sand. Ordinary silica builder's sand. Grain size 0.2 to 1 millimeter. The same material beneath every driveway, in every bag at every hardware store. NREL tested it. They heated silica sand to 1200 degrees Celsius over 2100 Fahrenheit and held it there for 500 hours. Then they measured every property they could think of. The result, no significant changes in any measured parameter. No degradation, no chemical change, no wear. The technology does not age. But here is the counterintuitive finding that makes sand batteries possible. Ville Kivioja, lead scientist at Polar Night Energy in Finland, demonstrated that heat applied to one side of a 1 meter block of sand at 500 degrees Celsius takes over 8 days to reach the far side. 8 days, 1 meter. The sand insulates itself. Sand's thermal conductivity is extraordinarily low, 0.2 to 0.7 watts per meter Kelvin. This is the same property that makes it difficult to extract heat quickly, but it is also what allows sand to hold heat for weeks without significant loss. The weakness and the strength are the same physics. Think of it this way. Your furnace fights to lift 15-degree January air to 68 degrees. Every morning at 7, when everyone else runs their heater, your electricity bill spikes. Your furnace cycles on and off all night. You wake up cold anyway. A sand battery is already holding 500 degrees. It is not generating heat. It is releasing heat that was stored when the sun was shining or the wind was blowing. The temperature difference does the work. No inverter required. Resistive heating works on DC. 4 solar panels wired directly to heating coils. No battery, no grid, no monthly bill. At commercial scale, the numbers become even more provocative. Polar Night Energy's Pornanen installation in Finland, 100 megawatt hours of storage. Cost approximately $25 per kilowatt hour of capacity, 1/4 the price of lithium-ion. But there is honesty required here. Jeffrey Gifford, postdoctoral researcher at NREL with a PhD from the Colorado School of Mines, co-authored the key paper modeling sand thermal storage. His framing is precise. The 95% storage efficiency was just focusing on the thermal energy left in the silos. In our paper, we calculated a round-trip efficiency of 50 to 52% for electricity to electricity conversion. 52%. Not 95, but residential heating does not need electricity back. It needs heat, and thermal round-trip efficiency, energy in versus usable heat out, ranges from 75% for small systems to over 90% at scale. The physics works, the cost works, the durability works. The material is the cheapest on Earth. The technology cannot degrade because there is nothing to degrade. So why has no American ever installed one? The answer is not a conspiracy. It is a system. The International Residential Code is the document that governs what you can legally build in 49 states. It prescribes specific materials and methods: concrete, dimensional lumber, masonry, light gauge steel. Everything outside that list must pass through IRC Section R 104.11, Alternative Materials, Design, and Methods of Construction. This is the variance process. It requires a registered professional engineer to analyze your system, $2,000 to $10,000. It may require third-party testing by UL or ICCES, $10,000 to $50,000 or more, and it requires approval from a building official who may never have seen the technology you are proposing. IRC, Chapter 14 adds another layer. All heating equipment must be listed and labeled according to specific UL standards. No UL listing exists for any residential sand battery. No UL listing exists for any solid thermal storage heating device. No listing, no category, no pathway. The professional society responsible for HVAC standards is ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers. In 2019, they published a design guide for cool thermal storage, ice storage, chilled water, commercial air conditioning. The document explicitly states that it covers neither the storage of energy for heating applications nor passive storage of heat in the building structure. The organization that writes heating standards has not written a standard for hot storage thermal systems in residential buildings. The gap is not accidental, it is structural. Now consider the appraisal system. Fannie Mae and FHA loan requirements mandate a functioning heating system for mortgage approval. Homes with non-standard heating receive significant value discounts or are deemed unmortgageable entirely. One documented case, a homeowner installed a $15,000 solar and battery system. The appraiser valued it at $0. A homeowner on Green Building Advisor wrote this: "It was really eye-opening to me how in this day and age when we should be assisting people into alternative energy homes, there are in fact nearly insurmountable obstacles put in place to keep people on this unsustainable path. Insurance creates the final catch-22. Imagine this: lightning hits your house. The fire department does its work. The insurance adjuster arrives to inspect the ashes. They find the steel drum, the heating coils, the mineral wool insulation. No UL sticker, no code approval. That thing there nullifies your policy. The code barrier, the appraisal barrier, the insurance barrier. None of them require a villain in a boardroom. They only require a system designed to certify manufactured products, not cheap, site-built solutions using commodity materials. But behind the system, there is an organization. The American Gas Association represents gas utilities across the United States. It is funded by member utility dues, which are passed to ratepayers. It maintains a building energy codes and standards committee that, according to their own published materials, opposes electrification efforts that would prohibit, negatively impact, or limit consumer choice for the direct use of natural gas. The mechanism is documented. AGA recruits American Public Gas Association members to bolster voting power at the International Code Council, the organization that writes the IRC, the IBC, and the IMC, adopted by 49 states. They coordinate testimony. They propose code language. They organize opposition to electrification provisions. In April 2018, a GTI employee wrote in an internal communication, "Massive forced switching to electric technologies under decarbonization policies is an existential threat to natural gas direct use in buildings." Existential threat. Their words, not mine. As of 2024, AGA had helped pass preemption laws in 25 states preventing cities from banning natural gas in new construction. They successfully reversed Berkeley, California's first in-nation gas ban, through federal court. Natural gas serves roughly 89 million American households, 46 to 47% of the home heating market. The residential heating equipment industry exceeds $12 billion annually. The top 8 HVAC vendors control approximately 90% of revenue. Emergency replacements, your furnace dies in January, you call someone, account for 60% of residential HVAC sales. The business model is proprietary equipment, license installation, periodic service, eventual replacement. A heating system that does not break, does not require service, and uses commodity sand is incompatible with this model. They update the building code every 3 years with committees that include HVAC contractors and equipment manufacturers. They publish compliance pathways that exclude site-built systems. They have built an appraisal structure that values a gas furnace at market rate and a sand battery at zero. They have created a licensing system with no category for thermal storage installation. They have funded preemption laws in 25 states to prevent cities from choosing alternatives. They describe electrification as an existential threat, and they are correct. A heating system you cannot meter is a threat to every business built on metering. In Finland, the story went differently. Business Finland, a government agency, funded both the Porninen and Vaxi sand battery projects. Finnish Minister of Economic Affairs Mika Lintilä attended the Kankaanpää inauguration on January 20th, 2023. The installation was named Finland's Productive Idea of 2023. It was featured on NASDAQ Helsinki billboards. It appeared in Times Square. Same physics, same sand, different government, different outcome. The question is not whether the technology works. It is whether anyone will build it anyway. In 2013, two engineers at Tampere University of Technology in Finland met and discovered they shared an obsession. Tomi Aronen, studying for his master's in power plant engineering, and Markku Ilonen, completing his doctorate in applied mechanics, kept returning to one question. Is it possible to build an energy self-sufficient and cost-effective hippie commune for engineers using only solar power? Their internal code name for the project, Hippie Commune. 3 years later, Aronen was researching water-based energy storage when he read an article about traditional Finnish fireplaces made from stone and sand. Would a solid material, rather than water, he asked, be more suitable for storing solar and wind energy? He and Ilonen built their first prototype in Aronen's grandparents' backyard cottage. In 2018, they founded Polar Night Energy. By April 2024, they had raised 7.6 million euros in seed funding. In 2025, Time named their sand battery one of the best inventions of the year. Aronen's framing is precise. When you ask people about cleaner energy, they think of electricity. But we also have to cut emissions from heating. The installations tell the story. Kankaanpää, operational since July 2022, 4 meters wide, 7 meters high, 100 tons of ordinary builder's sand, 100 kilowatts of thermal power, 8 megawatt hours of storage capacity, district heating for approximately 100 homes plus a public swimming pool, the world's first commercial sand battery, Porninen, the world's largest operational installation, 13 meters tall, 15 meters wide, 2,000 tons of crushed soapstone, 1 megawatt thermal, 100 megawatt hours of capacity, reduces carbon dioxide emissions by 160 tons per year, completely eliminates oil use, cost approximately $25 per kilowatt hour of storage, 1/4 the price of lithium-ion. Vaxu, under construction and expected to become the world's largest, 2 megawatts thermal, 250 megawatt hours capacity, 2,400 tons of locally sourced natural sand, expected to cut natural gas consumption by 80%, completion summer 2027, 0 installations in the United States, 3 in Finland. The physics has not changed, the politics has. But while governments debate, builders build. On Permies.com, a homesteader wired 4 260-watt solar panels directly to heating coils embedded in sand. No battery, no inverter, just photons hitting silicon, electrons flowing through nichrome wire, and heat entering sand. The 2-gallon test vessel hit over 1,000 degrees Fahrenheit. The builder eventually scaled to 100-gallon propane cylinder systems. On the DIY Solar Power Forum, an Arizona builder planned a 4x8 by 4 foot sand battery using 8 stovetop heating elements at 2,600 watts each. One forum member posted, "Yesterday, my sand battery hit over 600 degrees Fahrenheit. This morning, the lowest temp was 234 degrees. A 55-gallon steel drum, $30 to $60. Mineral wool insulation rated to 1,000 degrees Celsius, $30 to $50. A heating element from Amazon, $20. A high-limit thermostat, $15. Total materials under $300. One builder held 600 degrees overnight. For those who want a complete residential system, Batsen Eve, a Latvian startup led by Andre Raimundo, with approximately 20 years in sustainable architecture and a PhD in mechanical engineering, offers a 40 cubic meter underground sand vessel with 7,120 kilowatt hours of capacity. Sand vessel materials, 3,700 euros. Full system installed, 17,660 euros. With an 18 to 24 kilowatt solar array, 33,000 to 39,000 euros. Claimed payback versus gas heating, 8 to 10 years. Sand batteries are not alone. The pattern repeats across every technology that uses common, unpatentable materials to store cheap energy. Rocket mass heaters burn 70 to 90% less wood than conventional stoves through complete combustion in an insulated vertical chamber. Ernie and Erica Wisner have built over 700. Independent testing showed emissions of 0.12 grams per hour, 20 times below the EPA limit. Yet no UL listing exists for site-built rocket mass heaters. A couple in Jackson County, Oregon was ordered to remove theirs at $4,200 cost. The reason, it lacked a sticker. Trome walls deliver 70% of annual heating from solar energy through south-facing masonry behind glazing, invented by Jacques Michel in Odeillo, France in 1967. No prescriptive code pathway. Builders must navigate IRCR 104.11. Earth tubes provide free preheating in winter and pre-cooling in summer from constant ground temperatures at 1.5 to 3 meters depth. Common in Austria, Denmark, and Germany since the 1990s. Integral to the Passive House standard. No U.S. code recognition, no tax credits. Passive solar design demonstrated 70 to 90% heating energy reductions after 1978. Over 25 million buildings have been constructed since without it. Technologies that cannot be monopolized face systematically higher barriers than technologies that require proprietary equipment. Jeffrey Gifford at NREL understands why this matters. Particle thermal energy storage doesn't rely on rare earth materials, or materials that have complex and unsustainable supply chains. For example, in lithium-ion batteries, there are a lot of stories about the challenge of mining cobalt more ethically. The sand is already here. The physics is already proven. The question is whether we will use it. They will not tell you that sand stores energy at $4 to $10 per kilowatt hour, while their batteries cost $300. They will not tell you that the Korean Ondol has heated homes for 3,000 years and still heats 90% of South Korean homes today. They will not tell you that a 400-year-old stone heating system at Malbork Castle still worked in 1822, heating 850 square meters in 20 minutes. They will not tell you that Finland's energy minister attended the inauguration, that the project won national recognition, that the same physics exists beneath every backyard in America. They will not tell you because they cannot meter sand. They cannot pedant it. They cannot brand it. They cannot create a subscription for warmth that never stops radiating. We began with a number, $16 per cubic meter, $39,600 per cubic meter. Same function, storing energy, 2,500 to 1. The technology is not hidden because it failed. It is hidden because it succeeded too cheaply, using materials too common, solving a problem too completely. The sand is patient. It was patient in Korea 3,000 years ago. It was patient in Roman hypocausts. It was patient in medieval monasteries and Finnish soapstone stoves. It is patient now beneath every driveway, in every bag at every hardware store. The physics has not changed. Only the ownership structure of your heat supply has. A heating system that does not break, a material that cannot be patented, engineering that asks for no subscription, no service contract, no recurring bill. The building code has no category for it. The appraisal system cannot see it. The insurance forms do not acknowledge it, and it has worked for 3,000 years. Every share builds what they tried to bury. Every view is a vote for knowledge they do not want you to have. Next time on Off-Grid Secrets, there is a wall that heats itself. 12 inches of concrete behind glass, facing south. It was invented in France in 1967. It cuts heating bills by 7%, and the building code treats it like a fire hazard. The Trome wall, coming next.